All right, so let's look at this second type of problem. So problem type number 2 deals with the perimeter of rectangles. And so if you remember some pieces of information here that will go a long way. Number 1, the fact that for perimeter, we're literally talking about adding all the sides of that rectangle or whatever your shape is. And then also, there is some important information that we know about a rectangle. So we know that for a rectangle, let's do a better drawing. We know that for a rectangle, that the opposite sides are going to be equal. So we're going to assume that that's a rectangle here. So that means that whatever this side is, this side has to be also. Same thing for this. Whatever this side is, this side has to be also. So keep that in mind. And we have the length and we have the width of a rectangle. So let's look at this problem. It says the length of a rectangle is 6 inches more than its width. If the perimeter of the rectangle is 24 inches, find its dimensions. Meaning, when we are done, we need to find the length and the width of this rectangle. So here's some important information that we can go ahead and start to add here. It says the length of the rectangle is 6 inches more than its width. The length is 6 inches more than its width. So this has to do with some translating here. Okay? So the length, so we know that L, our length is, so remember is means equal. So our length is 6 inches more than its width. But the question is, do we know what the width is in this problem? We do not. And so since we don't know what the width is, we're just going to make L be 6 plus x. Because the length is 6 inches more than the width. And then once again, we know that our width is equal to x. We don't know what it is, but we know that our width is equal to x. And so with that information, we can go ahead and kind of piece together what this rectangle is going to look like. So we know that this is going to be 6 plus x because that's our length. And then that also means that we know that this is going to be 6 plus x. At the same time, our width, which we do not know yet, is going to be x on both sides. So now using this information and the fact that it said perimeter, we can actually go ahead and start to solve this out. Because they told us that the perimeter of the rectangle is 24 inches in this case. So what that means is I can take each side, so I can take 6x plus 6. I can take x. I can take 6x plus 6. And I can take my last x. And if I add all of those together, I'm going to be able to get my perimeter, which is 24. So remember, the process here is you want to go ahead and put together an equation, and then from there you can solve it. And so this is nothing new. We've been solving equations for the last few weeks. So in this case, we know the first step would be to combine like terms. So let me go ahead and combine my like terms. We can combine every x. So there are 4 x's here. So that's going to leave us with 4x. And then we also have a 6 and a 6. So that's going to leave me with plus 12 is equal to 24. Okay, you go ahead and solve that equation. So we're going to subtract 12 on both sides. We are left with 4x is equal to 12. Divide by 4. Divide by 4. We're left with x is equal to 3. And so what that tells us is x is equal to 3, which means our width is equal to 3. So that means this particular value is 3, and that means this particular value is 3. So our width is equal to 3. I'm going to write that down. And then we know that our length, we just said that our length is 6 inches more than the width. So if the width is 3, 6 inches more than that is to add 6. So that means that our length has to be equal to 9. Okay? So our length is going to be 9. Also in this case, it's important. They told us we're using inches, so we want to make sure we include our unit. Okay? But that is your answer. The width is 3, the length is 9. So all you're doing is putting together that information in order to find your answer. Now, I want you to look at number 7. I want you to read through it. I want you to try it. And then I want you to, so pause the video, come back. All right, so for number 7, it says the length of a rectangle is 3 centimeters less than twice its width. If the perimeter of the rectangle is 90 centimeters, find its dimensions. So notice here in red, I've drawn a rectangle, and then they told us that the length is twice its width, and then it also says 3 centimeters less in the beginning. Remember, less than is a turnaround phrase, so we're going to subtract, but it also means to turn around the order of the problem. And so that is how I came up with 2x minus 3 for our length. Notice our width, we don't know it, so we represent it with an x. When I go over to the rectangle, notice I have my x here for my width, x here for my width, and then for each length, I have 2x minus 3. So this is the basis of how we're going to work this problem out. Then, because we're talking about perimeter, we are going to, hopefully everybody knows it, we are going to add. So in this particular case, you should be adding those together. So when we add everything up, this is what we're looking like. Okay, so we've got our perimeter here. We've got 2x minus 3 plus x plus 2x minus 3 plus x is equal to 90. There's also a perimeter formula you could use in this case if you remember it. But now this is nothing new. So we start to solve it out. And so I'm going to show you here what I've got. Hopefully this matches what you have. So when we start to solve out this equation, we get 6x minus 6 is equal to 90. And we go through the inverse operations to solve that out. And I'm left with x is equal to 16. So since we know x is equal to 16, that is our width. So the width of each side is going to be 16. But that's not enough because it said find the dimensions. So we need the length and the width. So in order to find the length, we're going to take that 16 that we found for x, and we are going to substitute it back into our equation. So if you look here, notice, in order to find the length, we're going to take the original equation that we had, and we're going to plug in 16. So we're going to do 2 times 16 minus 3. 2 times 16 is 32, and then 32 minus 3 gives us 29. So that means our length is going to be equal to 29. The width is, the width is 16, but then the length is 29. All right, so for this last type of problem is essentially the same thing. So really, we call these different types, but they're all really working the same way. So in this case, though, we have Maria has 12 more than Chris, so $12 more than Chris. Together, they have $72. How much money does each have? So you're looking for two values. You're looking for the number for Maria, how much money she has, and then you're looking for the amount that Chris has. Now, in the problem, they tell us Maria has $12 more than Chris. But then, do we know what Chris has? They didn't say anything about what Chris has, so this is what I was able to come up with. Maria has, $12 more than Chris. We don't know what Chris has, so we're going to let that be represented by a variable. So we have 12 plus C for Maria, we have C for Chris. And then notice in the problem it says together, so that means we need to add. So we have Maria's amount, which is 12 plus C, plus Chris's amount, which is just C. And all of that needs to be equal to 72. And so now once you set up an equation, then you're simply going to solve it as we've been doing before. So as we solve this equation, let me show you what I was able to get. So we set it up. I combined my like terms, which left me with 2C. And then I go through the process, and I was able to get that Chris has $30. So that process let me know that Chris has $30. But once again, you're not finished. You need to find the amount for Maria. And so to find Maria's amount, all you have to do is take the 30 for Chris and substitute it into the equation for Maria. So notice what I have here. In this case, I had Maria is equal to 12 plus C. Instead of C, I'm going to plug in 30 because that's what we found. And then when I add those two together, I get Maria has $42. And if you wanted to check your work, you could do 42 plus 30 and see if that gives you 72. In this case, it does. So we're right. I want you to go ahead and look at problem 9. Try it yourself. See if you can set it up yourself and then come back. All right, number 9, last problem. it says the larger of two numbers is 7 less than 3 times the smaller number. We got a lot going on here. If the sum of the numbers is 61, find the numbers. So first thing here is we've got two numbers. We've got a small number and we've got a large number. So I like to break it down like this. I go ahead and write out what I'm looking for. I've got a small number and a large number. Okay. Then they told us that the larger number is 7 less than 3 times the smaller number. But did they say anything about the smaller number? No. So here's the thing. When we don't know what it is, we use an X to represent it. So notice I use an X for my small number. And then they say the larger number is 7 less than 3 times the smaller number. Remember that less than means subtraction, but it is also a turnaround phrase. So notice the 7 was in the front in the sentence, but when I wrote it out, it's now in the back. So be careful of that. So this is the smaller number, this is the larger number, and then it says the sum of those numbers is 61. So if we're talking about the sum, that means we're going to be adding these two values together. So if we go ahead and add these two values, well, let's see what that should look like. I've got my small number, which is x. I've got my large number, which is 3x minus 7. If I add those two together, they're going to be equal to 61. I begin to solve. So notice, combining like terms, inverse operations, I'm left with x is equal to 17 for the small value. But we're looking for two numbers here, so we've got to find the large number. And when I do that, I'm simply going to substitute the 17 into the equation for my large number. So I plugged in 17 here, and then I did the math, and I was left with the large number is 44. So, anytime you're dealing with these problems, the first step is to really kind of organize your thoughts. And so notice for each of these, I started writing out what we were going to find in the end. So for this problem, small number and large number. The problem before that, Maria and Chris. And even before that, the length and the width. Or even the consecutive numbers, first number, second number, third number. You're listing them out. Okay, then you're going to take what the problem gives you. You're going to come up with the algebraic expression that goes along with that, the equation that goes along with that, and then all we're doing is solving. Ain't nothing new. All right, so that's your goal for, or part of your goal for today.